sound you heard before the explosion.
Oh, yeah, good, Jimmy. That's the key. That's the key. You hear that? It's pauses. Do you hear the pauses? That's when we realize it's a pattern. It's a repeating pattern.
Mathematical?
Mm-hmm. That occurred to me too. There are distinct blocks within each pattern, and within each block, the tones come in groups of three. It's 3, 3, 3, 3, 3, 3. It's always 3, 3, 3. It's always the same. And see, for months I struggled to analyze it, trying different constructs, and then I thought about dimensions.
X, Y, Z coordinates.
Exactly. 3 groups equals 3 dimensions. So I assigned different graphic values to each block group and tone, and I came up with this. Hello.
Oh my God. Is that what I think it is?
DNA?
You see it?
Yeah. It's a model of DNA.
So somebody left that thing here. Okay. Somebody other than human. But, what is it?
It's a signature. It's a self-portrait of whatever species created the face.
That DNA looks human.
No, it's not. It's missing the last pair of chromosomes, see?
It's close. It's damn close.
Close. The difference between man and ape is less than 3% genetic material. But that 3% gives you Einstein, Mozart.
Jack the Ripper.
Yeah, he's right.
That's a clip from Mission to Mars, made in the year 2000. So it's already about 10 years old. And at that time, they were proposing the idea that this was information. DNA was information. It was not an accident. So these are the kind of things that are getting to the public. And that's where I'm coming from today, presenting this topic on information theory. I'm Mark Burton from the Mexico Science Foundation. In the beginning, God created matter. That was from verse 1 of Genesis 1. He also said in verse 3, let there be light. So he created energy. Einstein gave us this equation, E equals mc squared, that tied the two of those concepts together. But thirdly, God also created information. In verse 11, God said, let there be vegetation upon the earth. That was the first form of information upon the earth, but it existed in God before it came to earth. So I'm going to use a word I learned from a man I once knew called instantiation. That information was instantiated from God into that vegetation. And then in subsequent days, it was instantiated into various other forms of life. Information is power. Concealed information preserves that power, and it also makes information very controversial. So what's so controversial about information? If we tried to present a video like this at a science meeting, it would be laughed out of the room because we would say, well, it's from something else besides an accident. I've got a quote here from Mike Oard. He recently emailed me a couple weeks ago. This is an issue that's going to come up in the New Mexico legislature. He has asked Senator Gail Kernan and Representative Jimmy Hall to request that the controversial Science Topics Education Bill be put on the Legislative Education Study Committee's agenda. So this is a study committee. It's not even the legislature yet. They need to study it and then be able to vote successfully on it at a regular legislative session. They will try to do that, and we should know by June whether or not it is accepted. If it is accepted, we will need to plan testimony. Please check our website, originseducation.org, to see the proposed language and supporting information. So next slide, please. I'm going to talk about these areas during the presentation on information theory. The first area will be design, what that criteria is. We've heard a lot about design. Anybody can recognize design. Everything you see around you is designed. Look at something in front of you, behind you, aside of you. Then look at the person sitting next to you. Is that any different than the objects that have been designed? Are we any less important, or even, how would you recognize that design? If you can look at a chair and say it's designed, why can't you look at a person and say it's designed? I'm going to talk about cells as they reveal information about DNA. I'm going to talk about a particular quantity called AMP, ADP, and ATP. That's adenosine monophosphate, adenosine diphosphate, and adenosine triphosphate. I want to make this more than a lesson in biology, and a lot of you out there probably know more about biology than I do. I have a degree in systems engineering, so that makes me interested in why it works, not just the technical part of biology, but what am I looking for? I'm going to follow the energy. You've heard the phrase, follow the money. I'm going to follow the energy. This ATP is the energy of life. Now, God designed it as energy. So it's amazing, and we're going to look at one of the processes called metabolism and how that works. So metabolism includes glycolysis, Krebs cycle, and electron transport. I'm going to look at that in a single slide in a few minutes. Everybody's familiar with Windows 7, with OS 10, and Linux. You've heard those three. Which one would you say is an open source? Linux. Now I want to propose the question now. I'll let you think about it until the end of the presentation. Would you consider God proprietary or open source? So think about that during the presentation. Okay, next slide, please. The Bible says we are designed. I will praise thee, for I am fearfully and wonderfully made. Marvelous are thy works, that my soul knoweth right well. So the psalmist knew right well that we are designed. When our country was founded in Declaration of Independence, we hold these truths to be self-evident. We talk about our Creator. And now we hear that, no, we're not created anymore. We're just an accident, freak of nature. How to recognize design. This has been the controversial area, and I want to be on the leading edge of what's going on in our culture today. Design research is being done at this organization called Biologic Institute. I heard a presentation by Doug Axe a few months ago at the New Mexico IDNet meeting at the UNM Law Library. He's talking about the research, how to recognize design, and also how to test for evolution. They're testing sequences, how they could actually go from one form to another form. What would be the probability of that happening? So that's leading edge research in design. So when the evolutionists say, oh no, you're not a science, there's no testing you can do. Yes, we're doing testing to showing that your theory can't happen. And even they're coming up with the same conclusions. They've realized that life can't happen by itself. It's called spontaneous generation. We decided once that can't happen, but now they're deciding again, no, it's just so low a probability it can't happen. So probably in the last 4 to 5 years, they've created a term called panspermia, that seed came from outer space. There's a group called Harvard's origins.harvard.edu that's doing research in that area, sort of research, you want to call it research. They have this theory, and it's called panspermia. But they're kind of giving up on that as well, because once you identify it came from outer space, well, where did those things from outer space come from? So the most recent thing, I'll talk about more later, is the idea of multiverse, multi-universes. And this is actually a serious proposal to make evolution happen. I'll talk about more about that later. These 4 areas, function, form, complexity, and efficiency. Now these are 4 great areas for systems engineering. If something has function, what does it do? Something has form, it's made for that function. It has complexity. It's not a paperclip. Even a paperclip has sort of a little bit complexity. And it has efficiency. We can measure that efficiency. I've got a little picture of something down in the right-hand corner. What is that picture? Snowflake. Now this is being used to promote the idea of evolution through fractal generation, because you can sort of generate a snowflake mathematically by growing pictures. So they say, well, this represents the complexity of life. Does it really? It has form, it has complexity, but does it have a function? What would you say the function of a snowflake would be? To melt, do something. I think it kind of looks beautiful. That might be God's function. Is it efficient? It's hard to know efficiency if you don't have a function. So those 2 areas, to me, fail for a snowflake, even though it is complex and it has a form, but that form is based on the laws of physics. So then you step back to the laws of physics. Where did those come from? So I'm looking at a quantitative measure of design rather than just a qualitative. We've been talking for years about design, but how do we measure it? Next slide, please. Give you a perspective on size, starting with a coffee bean, going down to a grain of sand, amoeba, human egg, red blood cell, keep going there, we're only about halfway through. Chromosome, bacterium, virus, there's HIV in there, RNA, adenine, and the atom carbon. So back up just a hair. We're adenine, look at the adenine coming in. That's the energy packet I'm going to look at. That keeps coming up. It's a recurring theme in biology. So what is it and what does it do? So next slide. That gave you an idea of the size of the scope that we're talking about. If you were to hide information, where would you hide it? Maybe the smallest place you could put it? Well, God put it in the nucleus of a cell, and he called it DNA. We call it DNA, for a lack of a better term, I guess. Somebody invented the term.